Hi everybody, Assalamualaikum warahmatullahi wabarakatuh. We will continue our classes. Okay, thank you. Uh, Good evening. So we are now in the final exercise of this chapter. We are doing the exercise of application. So we only learn one applications only in this topic, which is Newton's law of cooling or Newton's law of warming. So as we have learned yesterday, I have I have teach you how to derive the equations of Newton's law. So this equation, actually, you don't need to derive it. You just need to remember the equations of Newton's law. In case there is a question ask you how to derive, then you need to derive lah, as I showed you earlier. So just in this exercise, we also have one question. Question number one. Newton's law of cooling states that the rate of change of temperature of an object is proportional to the difference between its own temperature and the surrounding temperature. Assume that T, capital T, is the temperature of an object or body at time T, and Ts is surrounding temperature. Derive the differential equation based on Newton's law of cooling. Alright, so in this equation, let's assume that T, capital T, this one is the temperature of an object. And time T, small letter t, is the time at any given time. Ts, so here we are using Ts or Tm, is the surrounding temperature or the medium temperature. Then we need to derive the differential equation based on the Newton's law of cooling. So given that Newton's law of cooling say that the rate of change. So when we say rate of change, of course, the rate of temperature, the rate of change of an object is proportional. So when we say proportional, the symbol of proportional is this one. The proportional to the difference between its own temperature. So the difference between its own temperature. So the difference is temperature minus surrounding temperature. So in this exercise, I use surrounding TS, TS or TM. It's okay lah. If you want to use TM, okay, TS also can. So derive the differential equation based on the Newton's law of cooling. So this is question number 1A. So how to derive this one? First, you need to transform this mathematical expression into differential equation. So in order to transform this one, when we say the rate of change of temperature is proportional, so to transform into equation, proportional actually means the rate of change equal to some constant multiply T minus Ts. So this is the differential equation. So we already derived the differential equation. So then question number B. Show that the solution of the differential equation in A is Tt equal to Ts plus A exponent minus Kt. So we have a negative sign here, right? Negative K. So why the value of K we put negative? This is according to the Newton's law of cooling, where the Newton law of cooling say that if the warm temperature, if the hot temperature we put in the cool temperature, the hot will be full. The temperature will be reduced according to the surrounding. So we need to put the negative sign. At sub B, we need to show the solution, where the solution, you must show that the function t is equal to Ts plus A exponent minus KT. Right, so in order to show this one, last time I have shown you we can solve the differential equation in A, where the differential equation dt over dt equal to minus k t minus ts. So this is the differential equation that I have shown to you. So last time, yesterday, we have solved or we have find the t by using separable equation. I also said that this equation, besides using separable equation, this equation also linear. So now, today, I would like to show you how we solve this equation by using linear methods, linear equation. First, we need to rewrite this equation in standard form using linear equation. So in the standard form, this one will be dt over dt minus k. So we express or we expand this expression. So minus k multiplied capital T minus k multiplied minus ts. So plus k ts. Let me write k clearly. Okay, k minus k multiplied ts. Then remember that the capital T here is the dependent variable, while small letter here is independent variable. So you need to rearrange this equation. So if I rearrange this one, dt over dt plus kt, this one equal to k multiplied ts. Now you observe that the dependent variable here and this one, so this one is the power 1. And we don't have any nonlinear term, for example, cos t, sin t, or t to the power minus 1 or t squared. So this one is already in linear form. So this equation here actually is the general form of linear equation in differential equation. So in order to solve this one, you need to find the integrating factor. So to find the integrating factor, so this is mu t, not mu x. Why mu t? Because we have the independent variable here, t. If the below here is x, then mu x. Uh, so here we have mu t. So how to find integrating factor? So mu t is exponent integrations of px. So which one is px? Px is k. So mu t is exponent integrations of k with respect to dt, not dx, dt. So when you integrate k, where k is the constant with respect to t, so what you get is kt. So we have exponent kt. So multiply exponent kt. So multiply exponent kt with each term in the general form of linear equation. So exponent kt multiply dt over dt plus exponent kt multiply kt equal to exponent kt multiply k times ts. The left hand side of this equation you can simplify as d over dt multiplied mu t. Yeah, so our mu t is exponent kt, and the dependent variable is capital T, temperature, while the right hand side is just the same, exponent kt times k times ts. Then to get rid of the integration, to get rid the d over dt, so what we do is we integrate this one. So integration and the symbol of differentiation will cancel out. So integrate both sides. So if we integrate both sides, we will have exponent kt t equal to integration of exponent kt times k times ts. Remember that k is a constant, ts, which is surrounding temperature, also constant. So both are constant. So you can put constant outside. So this one is integration with respect to t, with respect to time. So because k and ts is constant, so we can put this one outside and then multiply with the integration of kt. So integration of kt is exponent kt divided by t. Divide by k, yeah? Differentiation of kt. So k and this one can be cancelled out. So what we get here, we will get exponent kt multiply t equal to ts exponent kt plus c. So don't forget plus let me go back. Don't forget to plus the constant c. So we have ts exponent kt plus c. Then to solve for t, each term here divide by exponent kt. So ts exponent kt divided by exponent kt plus c divided by exponent kt. So exponent kt divided by exponent kt equal to 1. So we have ts plus c exponent negative kt. So I put this one upside here, so I need to plus negative sign. So became this one. So now this one is the same as the equation shown in the, we need to show the equation where ts plus a exponent negative kt. So we can change the constant from c to a, yeah? Whatever numbering we want to use, whatever alphabet we want to use, a or c, doesn't matter because a is a constant, c also a constant. So we can leave this answer is like this. So you get also the same answer if you use linear equation. If you want to use the separable equation, also can. I think separable equation is more easier, more shorter than compared to linear equation method in this case. Alright, so I give you time to copy this one if you want to take a screenshot for this solution. 5 seconds. Alright, next one. Another 5 seconds. Alright. Next question is question B. Question number 2. At 2 p.m., initial temperature of chocolate cake is 300 degrees Fahrenheit. After 10 minutes, the chocolate cake cool to 200 degrees Fahrenheit. Given that the room temperature is 60 degrees Fahrenheit, determine when will be the chocolate cake cool to 62 degrees Fahrenheit. So let's jot down what is our clue given in this exercise. So at 2 p.m., initial temperature of chocolate cake is 300. So when we say initial temperature, that means at T equal to 0. So I can say that when T equal to 0, the temperature of chocolate cake is 300 degree Fahrenheit. After 10 minutes, that means we consider the T, small letter T time in minutes. So that means after 10 minutes, T10, the chocolate cakes now the temperature is 200 degree Fahrenheit. Given that the room temperature is 60 degree, so Tm or Ts, let's use Tm, is 60 degree Fahrenheit. Determine what? Determine when will be the chocolate cake cool to 62 degree Fahrenheit. So we need to determine what is T, given that the T equal to 62 degree. So all of these are our information just from the question. So let me copy this information, then paste here. All right, let me paste here. This is question number 2. Also, we know that initial temperature is 300 degree. We know that at initial 300 degree, this is when the clock is 2 p.m. Here at 2 p.m., initial temperature is 300. So this is at 2 p.m. Let's jot down this one because we need to determine the time. Right, so we have the equation where the equation, you don't need to derive the equation. If the question asks you to derive, just as in question 1, you need to derive. If the question didn't ask you to derive, then you just write down the formula for temperature at any given time t. Or I don't need to use this one. You need to write this one. This is equal to Ts or Tm plus C exponent minus Kt. Ts or Tm or A exponent Kt, yeah, minus Kt. All right, let's find out the two unknown constant first. We have the first one is C. This is unknown. The second one is K, also unknown. We know Ts. So from here, the Ts is 60 degree Fahrenheit. So when T naught, when time equal to 0, the temperature is 300. So 300 equal to 60 plus C exponent minus K times 0. So 300 minus 60, 240 equal to C multiply 1. So here we know that C is 250 degrees. So this implies T equal to 60 plus 240 exponent minus KT. We already found the value C. Now we need to determine the value K. So we can use the second information. Second information is when T equal to 10 minutes, the temperature is 200 degree. So when T equal to 10 minutes, the temperature is equal to 200 degree. All right. So substitute into our equation 200 equal to 60 plus 240 exponent minus k multiplied by 10. 200 minus 60, 100. 140 equal to 240 exponent minus 10k. So solving for k, so this one should be easy for you. 100 divided by 240 equal to exponent minus 10k. So in order to get rid of exponent on the right hand side here, because we have exponent, so why don't we put ln left hand side, ln right hand side? So if I take a ln of 140 divided by 240, so I will get 140. Here we get negative 0.5389997. On the right hand side, exponent and ln will cancel each other, so we have negative 10k. So find the value of k. K equal to, divide by negative 10, so k equal to 0.0538997. So I just take about 1, 2, 3, 4, 5, 6, 7. 7 decimal point. It's better you take more decimal point if you can. So now we have the value for k, then we can rewrite this equation in full. So t equal to ts, where ts is 60 plus c, 240 exponent minus k. So minus, don't forget, put minus. K is 0.0538997 multiplied t. So this is our equation. Right, next, we need to find what is the time when the cake cool down to 62 degree Fahrenheit. Here, when the cake temperature is 62, what is the value for T? So continue next page. Let me copy this one first. So copy. This here. But when T equal to 62 degree, what is the value for T? So 62 equal to 60 plus 240 exponent minus 0.0538997 T. So solving for T, so 62 minus 60, this one equal to 2. 2 equal to 240 exponent minus 0.0538997 T. 2 divided by 240, 240 exponent minus 0.0538997 T. Then take ln both sides. Negative 4.787491. This one equal to negative 0.0538997. 0.0538997 T. So T equal to about 88.82 minutes. So this is about 88.82 minutes, or it is almost 89 minutes. It is almost 89 minutes. Huh? So we need to find what is the time. So 89 minutes, if we convert into hours and minutes, this one is equal to 1 hour minus 60, 1 hour, 29 minutes. 1 hour, 29 minutes. So the cake initially is at 2 p.m. Initially, this is at 2 p.m. So because the time is positive, then it will be cooled down after 1 hour 29 minutes to reach 62 degrees Celsius. So the time will be 2 p.m. plus 1 hour 29 minutes. So we have 3:29 p.m. So at around 3:29 p.m., the temperature will reach to 62 degree, will cool down to 62 degree Fahrenheit. All right, I give you 5 seconds to copy this one. Question number 2. Take a screenshot. 5 seconds. 5, 4, 3, 2, 1. Next one. 5, 4, 3, 2, 1. All right, move to the next question. I will do about 5 questions. Huh? Then I will leave the rest for you to study on your own. We already have the answer. So you can study the other question. So question number 3. One incident of homicide was happened in a small town at Miami. Police inspector arrived at the crime scene at 1 o'clock in the evening. 1 o'clock in the evening. 1 p.m. This one is 1 p.m. He found the dead body on the floor and immediately measured the temperature of the body. The temperature of the body at time is 34.5 degree Fahrenheit. So this one, let's jot down this one. Initially, keynote at T0 is 34.5 degrees Celsius. This one happened at 1 p.m. He then left the body for 1 hour. So he left the body for 1 hour. That means after 1 hour, he measured the temperature again. And the temperature becomes 33.7 degree. So now, in example number 2, we measured T in minutes. So in this example, we measured T in hour. So let's write after 1 hour. So T1, the temperature became 33.7. Assume that the surrounding temperature is 27. So Tm is 27. And the normal temperature of the body is 37. Find the time of death of the body. So we don't know what is the time of death of the body, but we know that when we found the body, initially the temperature is 34.5 degrees Celsius. After 1 hour, the inspector measured again from 34. After 1 hour, it became 33.7. the temperature of surrounding. So in this room, the surrounding temperature is 27. So we need to find what is the time of that. We assume that normal temperature is 37. So we need to find what is T at temperature 37 when we alive, when we live, we alive, our body temperature is 37. So when we dead, our body temperature will slowly cooling to the temperature of our room, 27 degree. All right, we need to find what is the time. So when we use the T in hours, of course, we will get here in hours. Then later we need to minus the with 1 p.m. We will go back in time. Well, let's copy all this information. Copy this one, and then let me paste the next page. Right, so this is all the information that we have on the example number 3. Right, first, let us write down the Newton's law of cooling. So Newton's law of cooling say that T equal to Tm plus A exponent minus Kt. A exponent minus Kt plus Tm also can, whatever lah, as long as you get the correct equation. All right, now at T naught, when time equal to 0 initially, so at T naught, the temperature is 34.5. So 34.5 equal to Tm is 27, A is unknown, exponent minus K, T is 0. So 0 times K, 0, exponent 0 is 1. So 27, 34.4, 34.5 minus 27 equal to 7.5 equal to A. This implies T equal to 27 plus 7.5 exponent minus Kt. Then we need to solve for K. So solve for K by using second information. When time equal to 1 hour, the temperature equal to, after 1 hour, 33.7. Alright, this implies 33.7 equal to 27 plus 7.5 exponent minus K multiplied 1. 33.7 minus 27, 6.7 equal to 7.5 exponent minus K. Six point seven divided by 7.5 equal to exponent minus K. So take ln both sides. 6.7 divided by 7.5. Negative 0.112795 equal to minus K. So K is positive 0.112795. So we have the full equation. So T equal to 27 plus 7.5 exponent minus K, 0.112795 multiplied T. So what happened when the person was alive? When the person was alive, the temperature is 37. So we need to find what is the T before. So 37 equal to 27 plus 7.5 exponent minus 0.112795 T. So 37 minus 27 is 10. 7.5 exponent minus 0.112795 T. Okay, next 10 divided by 7.5 exponent minus 0.112795 T. Take along both sides. So 0.28768 equal to negative 0.112795 T. Hence, T equal to negative 2.55 0 point negative 2.550486 hours. So around this time. So around this time. So that means you need to consider the time when we found the body. We found the body at we found yes. Ada soalan eh? We found the bodies. The inspector found the bodies at 1 o'clock in the evening. So the body found is 1 o'clock in the evening, 1 p.m. or 1 p.m. If I try to convert, 1 p.m. is 13.00 international time. 2.550468. So you need to convert. This one is the first part. This one is 2 hours. So that means we have 2 hours. And this one, 0.55048. So you multiply with 60 to convert into minutes. So multiply by 60. This is about 33 minutes lah. Around 33 minutes. So 2 hours, 33 minutes. That means the time we found the body is at 13 hours, 1 p.m. That means this person was live negative because negative. That means the person was live 2 hours 33 minutes before. 2 hours 33 minutes before. So you minus 2.33. All right. So here will be 2. Here will be 60 minutes. 60 minus 33, 27. This one will be at morning lah. This one is evening. So about at 10:27 a.m. we found the body, yeah? And not found the body. The the body was alive at 10:27 a.m. find the time of that. So around 10:27 a.m. the body was alive. Then after that, he died. All right, so let's copy this one. Take a screenshot if you, which one? Okay, number. Right, done. Question number 4. I think I will do just one more. I think the other question I found that almost the same. So let's do one more question. Question number 4. If the body cools from 80 degree Celsius to 50 degree Celsius in 20 minutes, where the surrounding temperature given as 10 degree, how long does it take for the body to cool from 80 to 50 degrees? Question number 4. If the body cools from 80 degree to 50 degree in 20 minutes, so T note initially at T equal to 0, time equal to 0, temperature is 80. At T20 after 20 minutes, the temperature is 50 degree. So we have two information. Next information, surrounding temperature given 10 degrees. So Tm equal to 10 degree. So 80 degree. So how long does it take for the body to cool from 80 degree to 30 degree? So all these are the same information as we have in the question number 3. So let's copy this one. Question number 4. So let's write the Newton's law of cooling. T equal to Tm plus A exponent minus Kt. So here when T equal to 0, the temperature is 80 degree. So 80 equal to Tm is 10, A exponent minus K multiplied 0. So 80 minus 10, 70. So A multiplied by 1, A, so A is 70. So now we have one information, T is 10 plus 70 exponent minus Kt. Next, we find K by substituting when T equal to 20 minutes. The temperature is 50 degree. So 50 degree are equal to Tm. Tm is 10. A is 70. Exponent minus Kt. So solve for K. Sorry, T is 20 minutes. Okay, now you can solve for K. So 50 minus 10, 40 equal to 70 exponent minus 20K. 40 divided by 70 equal to exponent minus 20. K, solving for K. So what the value you get for K? So ln 40 divided by 70 divided by negative 20 So I found that the value of K is 0.02798. This is the constant. This implies that the temperature is equal to 10 plus 70 exponent minus 0.02798. 2798 multiply T. T equal to 10 plus 70. Okay, correct. So we want to find what is the temperature, what is how long the body takes to cool from 80 degree to 30 degree. So now when T equal to 30 degree, what is the value of small t, yeah, time. So 30 equal to 10 plus 70 exponent minus 0.02798 t. So solve for t. 2798 t, then divide by 70 here. Just do the routine lah. You also know to solve for t. Then t will be take along 20 divided by 70 divided by minus 44.77 minutes. So about 44.77 minutes. So to cool down from 80 degree to 30 degree, it takes about 44.77 minutes. So this is for A. For B, from 50 degree to 30 degree. 50 degree to 30 degree. So if you look at back from the question, to cool from 80 degree to 50 degree is 20 minutes. Then to cool from 50 degree to 30 degree, if I draw this one for B. So 80 degree to 30 degree, to cool from this one is around 44.77 minutes. And from 80 degree to cool from 80 to 50 minutes is around 20 minutes. So what is the rest from 50 to 30 degrees? So you just take 44.77 minutes minus 20 minutes. Minus 20 minutes. So this is around 24.77 minutes. No need to compute again. Just take this one. Alright, finish question number 4. So you can copy this one. And another one, this one also helps to imagine lah what I told you in 24.77 minutes. Okay, so you do the rest, question number 5 and so on. I hope you can do on your own lah, because I have found that this question 5, 6, 7, almost the same. We already done this one, so you can try to do on your own. Alright, that's all for our chapter 1. Alright, before we finish, we wrap up. Let's take a look back lah what we have learned so far in this chapter. So let's recap what we have learned so far. So so you have learned first is to verify the solution. To verify the solution. What is the solution for differential equation? So given the differential equation, let's say we have a function dx over dt equal to 2x, for example. So what is the solution? We looking a solution in terms of function xt. So how now I want to find the function of xt? By looking the dependent and independent variable. So I want to find the function xt. So xt is the solution. So if you ask to find, to verify the solution, let's say you are given a function xt. For example, is function xt equal to exponent 2t? For example, this function is the solution. This function xt exponent 2t is the solution. So how you want to do this one? Look back in the differential equation you have. You have a derivation of xt. So you need to substitute lah. So differentiate first time. So find xt dx over dt. So this one is exponent 2t over 2. And then substitute into the equation. So substitute dx, dt, and x into the differential equation. So you substitute back this one, exponent 2t here equal to 2 multiply x here. Thus, you get the same answer. If not, then this is not the solution. So, exponent 2t over 2 equal to 2 multiply exponent 2t. So, this is not equal. Hence, this one is not a solution. xt is not a solution. So this is one way how you can verify a solution. This is what you learn during your first class. If you are asked to verify a solution. Then, given the differential equation, you have learned to solve the differential equation by using 3 methods. So first method is separable equation. So separable equation, you have the left-hand side. You have, let's say you have dx over dt equal to exponent 2t. To determine whether this is separable equation, you must do the manipulative. You must to arrange this equation so that you can write all the x on the left hand side, all the t on the right hand side. So in this equation is very simple. So on the right hand side, you don't find any x, no x, only t. So you just can rearrange left hand side only x, right hand side only t. Then integrate both sides. So integrate 1 with respect to x, so you get x. Integrate exponent 2t, you get exponent 2t over 2. So this is how you do the equation or the solution. This is separable equation. Second one, you learn also linear equation. So linear equation, you need to rearrange the equation into the standard form. For example, dy over dx plus 2y equal to 3. So find out whether this one is linear equation. So this one is a linear equation because the y power is 1. We have the coefficient of dy dx is also 1. If not 1, then you need to divide by this coefficient. For example, this is 2x. So you need to divide everything by 2x. So 2x divided by 2x. Here also divide by 2x. Here also divide by 2x. So you have dy dx plus 2. Sorry. So you have 2 divided by 2. So 1 over x. Y equal to 3 over 2x. So this one is in linear form, standard linear form. Then you need to find the integration factor mu x, where integration factor equal to exponent px. What is our px? This one is px. So exponent 1 over x. After that, you multiply mu x, which is term. So mu x multiply d over dx plus mu x 1 over x y equal to mu x 3 over 2x. Then simplify the right hand side. So this right hand side will be mu x multiply y. This one will be d over dy. So here will be mu x 3 over 2x. And then integrate both sides and then simplify for y. That is a linear equation. And the last method is exact equation. So exact equation, you have m dx plus n dy. The equation must be written in general form. You must have a function of m with respect to x and a function of n where the derivative is y. And this is must equal to 0. If not equal to 0, then you cannot use the exact equation. So first, test for exactness. So how to test for exactness? Find the derivative dm over dy. Find the derivative dn over dx. Show that d del m over del y are equal to del n over del x. Show that this one, then you can make a conclusion. This is exact. Then find the solution. The solution will be in terms of f x y equal to some constancy. So you can find f x y by integrating m with respect to x plus some function ay. After you get this one, then find the derivative del with respect to y and make sure this is equal to n, and then you can solve for a prime y. After that, integrate to get ay, and then you just substitute back into the equation. Then lastly, you have the applications of Newton law of cooling. So Newton law of cooling. So for the Newton law of cooling, you have the function dt over dt equal to negative k t minus tm. If you ask to find the solution, if you want to find the solution, you can use separable or you can use linear equation. To find the separable, just dt divided by t minus tm minus k times dt. Now we have separate the variable t, capital T on the left hand side, variable t, small letter t on the right hand side. Integrate both sides. So right hand side you get ln t minus tm right hand side you get minus kt plus constant c. So take exponent both side, put both exponent. So exponent and ln. Now you have t minus tm. Here you have exponent minus kt multiplied exponent c. This is by using the ln rule. This one you can convert into this one. Exponent c also just a constant. Now let's rename this constant exponent c as a. So a exponent kt. So t became tm plus a exponent minus kt. So you have solved the equation. So this is the equation that you use in solving the Newton's law of cooling. All right, so I will give you the link for attendance. So please fill your attendance in the link given in the message in this Google Meet. You can find the link. Please fill the link for today's attendance. Yesterday lesson already came out in the video. I already trimmed the video. I will upload into the YouTube for your reference. Later, I will give you the link. And today's lesson also, I will give the link for you next time. With that, I dismiss our class. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you,
Ya, terima
sir.
kasih.
Thank you, sir.
Waalaikumsalam, sir.
Waalaikumsalam.
Waalaikumsalam, sir. Thank you.
Terima kasih, sir.
Thank you, sir.
Thank you, sir.